Hi, I'm David Bolton of GoParallel, and today I'm going to talk about using Numba in Python. It's a Python package that compiles Python code to machine code to make it run faster. It can be very fast in the right circumstances, but there's a caveat that you need to know. The example program, that's called ex2.py, creates a list of odd numbers. It then adds 2 to the start of the list. Then it calls a function isPrime for every number in the list to determine if it's a prime. And 2 is the only even prime number we need to check for, so the list holds odd numbers for the rest of it. And it does this checking for prime by dividing the square root of a number by every odd number from 5 upwards. If none have a 0 remainder, then the number's prime. We've optimized this to use Numba, and the 2 lines from Numba import JIT and then the @JIT. Let me move this over a bit so you can see it. That's the decorator on the isPrime. That's all that's needed to have Numba do its magic. Behind the scenes, the LLVM compiler compiles the isPrime function into machine code. There's an optimization here at work which you may not know about. It's known that any prime number appears to be next to a number divisible by 6. So 11 is next to 12, 13 is next to 12 as well, 17 is near 18, as is 19, and 23 is near 24, and so on. So let's run this program from within IPython to make it easy to time. From the Python command line, IPython command line, the command is %time %run ex2.py. That's here, and just so you can see the program on the left hand side. It's set up for 1000, so we run this, and you can see there's the timing. IPython times has 3 times. There's user time, system time, and the total of those 2. And there's also wall time, which is like a clock, so it's totally elapsed time. I've run the program 3 more times, increasing the number of numbers to check by 10 times each time. So we've got 1,000, 10,000, 100,000 and a million. And the times there, really the one that really counts is the user time. It's 56 milliseconds, 88 and 472 milliseconds. So it's interesting that out of a million numbers, half a million odd numbers, it found 78,498 primes in just under half a second. That's pretty quick. Now, this is where the caveat that I mentioned earlier, that compilation takes time. And on my PC, which is pretty quick, I think it roughly takes about 36 milliseconds. That's from experimenting before. So for small numbers of primes, if we run this without Numba, the Python code should be fast enough. So let's give it a shot. Right, I've edited the program and just commented out the first from Numba and also the @JIT. And then I've rerun the program for the 4 time periods, and here you can see the time is 4 milliseconds, 12 milliseconds, 168 and 3.73 seconds. It's clear that Python without Numba is faster for 1,000 than for 10,000, and I reckon it's somewhere around 50,000 where the crosses over where it doesn't really matter if it's Numba or Python. It'll take about the same length of time. For 100,000, Numba takes 88 milliseconds. That's almost twice as fast than Python at 168 milliseconds. And for a million, it's nearly 7.5 times faster. I did it for 10 million as well, and Numba works out about 10 times faster. So what's happening here? Is that compilation overhead at play, I believe. For small numbers of primes, it's quicker to check and it executes in less time than the LLVM compiler does its work. As an analogy, it's like a van, Python, racing against a train, Numba. Both start together, but the van has greater acceleration and gets ahead more or less straight away. But once the train gains enough speed, it'll pass the van and reach the destination first. Numba is incredibly easy to use, and so long as the computation is not lightweight, you should see gains. The more intense the computation, then the better the gains will be. There are other features of Numba as well. You can specify the function parameter types, you can cache generated machine code, target CUDA for running code on the GPU, and compile Python classes and create universal functions. I think it's really wonderful, and it's so easy to use. Thank you for watching. I'm David Bolton of GoParallel.